Okay, get ready to rethink everything you thought you knew about the cloud. We're not talking about servers in a warehouse somewhere. We're talking about launching data centers into orbit. Today we're digging into Google's wild plan to put computing in space, and we are going to separate the sci-fi rumors from the actual incredible reality. Let's get into it.
So let's just rip the Band-Aid off and start with the biggest, wildest rumor out there, the one that's been flying around the internet. Is Google really building a data center on the actual moon? And is it happening by 2027? I mean, it sounds like something straight out of a movie, right? But this is the idea that's got everybody buzzing.
So here's how we're going to break it all down. First, we're going to tackle that moon rumor head-on. Then we'll get into the real project, which is called Suncatcher. We'll explore why on Earth we'd even need to look to space, how this crazy tech actually works, the massive challenges it faces, and finally, what it could all mean for the future.
All right, first things first. That whole lunar data center story. Is there any truth to it at all? Let's separate the facts from the fiction.
Okay, here's the deal. The rumor says there's going to be a physical building on the moon. But the reality? It's actually solar-powered computer hardware in Earth's orbit, not the moon. So where did all the confusion come from? Well, it seems to be from the term moonshot. See, at Google, a moonshot is just their internal slang for any big, ambitious, high-risk project. It's a metaphor, not a literal blueprint. So the main takeaway here, we're talking about orbit, not the dusty surface of the moon.
And you know, there are some really solid reasons why a moon base just isn't happening anytime soon. For one, you've got these insane temperature swings. Then there's the lunar dust, they call it regolith, and this stuff is like superfine glass that gets into everything and just destroys electronics. Plus, you have a communication lag of over a second, which in computing time is an absolute eternity. You know, academic studies have looked at this, and they all pretty much say a moon data center is something for the distant future, if it ever happens at all.
So if it's not a moon base, then what's the real story? Well, it's a very real orbital project called Project Suncatcher.
Okay, so what is Project Suncatcher? Simply put, it's Google's plan to launch a whole bunch of satellites packed with their super powerful custom-built AI chips. These are called tensor processing units, or TPUs. Think of them as engines built specifically for artificial intelligence. And the whole network is designed to be powered by the sun, so it can handle massive AI tasks in a much cleaner, more sustainable way. Now, this whole idea didn't just pop up out of thin air. It's really a response to the massive explosion in data centers that we saw back in the 2010s. Google officially announced Suncatcher in late 2025, and they're actually planning to launch the very first test hardware in early 2027. And their long-term dream? By the 2030s, to have huge, scalable clusters of these things all working together up there in orbit. But that just brings up a huge question, right? Why? Why go to all this incredible trouble and expense? Why put data centers in space at all? Well, it turns out it's all about solving a gigantic and rapidly growing problem right here on Earth, the AI energy crisis. Just let this number sink in for a second. 100 million tons of CO2. That's what data centers in the US alone are estimated to have pumped out in recent years. AI is amazing, but that power comes at a staggering environmental cost. And to really get a sense of the scale of this problem, a single large data center can use as much electricity as a small city. That's just one. As AI models get more and more complex, their thirst for energy is just skyrocketing, and it's putting a huge strain on our power grids and our water supplies. This is exactly where space starts to look like the perfect answer. In orbit, you get sunlight 24/7, nonstop. Solar panels are way more efficient up there, up to 40% more, because there's no atmosphere to get in the way. You also completely get rid of the need for billions of gallons of water for cooling, and you sidestep all the political and environmental fights over where to build these massive facilities on the ground. Okay, so the why is pretty compelling, but how does this system actually work? Let's dive into the nuts and bolts of the tech that makes Project Suncatcher possible.
The whole process really breaks down into 4 main steps. First, they launch these constellations of specialized satellites. Once they're in orbit, they unfold their solar panels and just soak up that constant solar power. Then, they use that energy to do the really heavy lifting for AI, things like training massive neural networks. And finally, all that data gets beamed between the satellites and then back down to Earth using incredibly high-speed lasers.
And that last piece, the lasers, that's the real magic here. It's a technology called free space optical communication. You can basically think of it as a wireless fiber optic network in space. We're talking about moving data at terabits per second. It's this communication breakthrough that makes the whole idea of a network of orbital data centers actually viable.
Now this all sounds pretty amazing, but let's be real for a second. Launching delicate, complex computers into the harsh environment of space is, well, it's incredibly hard. Let's look at the major hurdles that Google and its partners have to clear.
All right, let's break down the big challenges. First up is latency, that communication delay. For something like training a huge AI model, which can take weeks, a tiny delay doesn't really matter, so they'll focus on those kinds of jobs. Then you've got space debris. To deal with that, the satellites will need advanced thrusters to dodge junk. Third is radiation. Cosmic rays can fry electronics, so they'll need special shielding. And finally, the biggest historical barrier, the cost of just getting to space, has been coming down dramatically thanks to reusable rockets. So for every problem, there's a potential solution, but the engineering challenge is still absolutely massive.
So let's say they can pull this off. Let's say Project Suncatcher works. What would that actually mean for us, for technology, for the planet? Let's zoom out and think about the really big picture here.
Honestly, the potential impact is enormous. First off, you'd have a truly sustainable, carbon-neutral way to power the future of AI. It could also bring supercomputing power to remote parts of the world that just don't have the infrastructure now. What you get is this new hybrid ecosystem, where computers on the ground and in space work together. And just imagine the possibilities for things like real-time disaster response or climate monitoring, processing satellite data almost instantly. And we need to be clear. This isn't just some cool, nice-to-have science project. According to a report from the Brookings Institution, the energy demand from AI could literally double by 2030. Without some kind of radical new solution like orbital computing, that growth just might not be sustainable. The need for this is very, very real.
So, at the end of the day, we're left with this massive question. We've seen the incredible promise, but we've also seen the daunting challenges. Is this the dawn of a new era for computing, one where we move the heavy lifting off-planet? Or will the technical hurdles be too great, leaving it as a moonshot in the truest sense of the word? An amazing idea that's just out of our grasp? I guess we'll have to wait and see.